Use algebra to solve the equation cos x equals 1 minus 3 cos squared. Again, we have a quadratic equation like we had in 3, but this time we have another cos. So what we're going to do is we're going to say, well, in grade 11, when we had quadratic equations, we moved everything over to one side. So I'm going to add 3 cos squared x and subtract 1 on one side and make it equal to 0. With a quadratic equation, my options are to try to factor or to use the quadratic formula. Now, if I try to factor this one, the question for you is, how long does it take you to realize it can't be factored? If it's 3 cos squared, it would have to be 3 cos and cos. That's your only option because those are prime numbers. Your last number is a 1. It would have to be 1 and 1. Can my outside and my inside ever make 1? No. So I try this first only to find out that I can't factor it. If you can't factor it, your quadratic formula on your formula sheet says for ax squared plus bx plus c equals 0, x is equal to negative b plus or minus b squared minus 4ac all over 2a. But we don't have x squared. We have cos squared. But we do have values in front of cos squared, a value in front of cos, and a number by itself. So our next step will be, instead of writing x equals, it will be cos x equals negative 1 plus or minus b squared would be 1 minus 4 times a times c divided by 2a. If I simplify this, I get negative 1 plus or minus the square root of 13 over 6. That actually gives you 2 equations. It gives you one equation with the positive, negative 1 plus the square root of 13. It doesn't look like a 13. Over 6. And one with the negative. So the quadratic formula is what's needed to get cos by itself. Notice in all of the questions that we've done so far, that's been the first thing we needed to do, is get our trig function by itself. Once you get a trig function by itself, you have to decide, is this calculator or is it non-calculator? Is negative 1 plus the square root of 13 over 6 on your unit circle? No. So this is obviously going to be a calculator question. Okay? Since it's a calculator question, I am going to find out what this value is. Because right now, I don't know if this is obvious to you if this is positive or negative. I don't know if it's obvious to you if this number is bigger or less than 1 because of the values that we have. So I'm going to go to my calculator. If you have the fraction button on your calculator, very nice. Negative 1 plus the square root of 13 divided by 6 gives me 0.434. So I'm going to write that down. And if you have a calculator that doesn't have the fraction button, type that in to make sure, do you get negative 0.434? I'll show you the most common calculator error that people do. Can you see yourself doing this? Negative 1 plus, well, most common, a common calculator error. Negative 1 plus 13 divided by 6. That looks very similar to what we had. But when I push enter here, I get the wrong answer. What's gone wrong? Well, your calculator does order of operations. It just divides the root 13 by 6 and then adds a -1 after. If you're typing it this way in your calculator, you will need brackets. -1 plus the square root of 13 bracket divided by 6. Then you will get the -0.434 like we wanted. But if you have this fraction button, it is a lot nicer because you can type it exactly as you wrote it. I'm also going to just change this sign in the middle to a subtract sign. Push enter, -0.768. To get the answer on both sides. Okay. Well, both of them are possible. One of them cos is positive. The other cosine is negative. What do? We will need to find our reference angle. So for this one, our reference angle will be cos inverse of this value. Go to my calculator. Cos inverse of this value. You may need to retype it in, depending on what calculator you have. And my angle is 64 degrees. Was this question in degrees? No, it's in radians. So you're like, oh, I have to redo it. Change my mode into radians. Retype this. And now I figure out that my reference angle is 1.12. I'm going to store that value as x because now cos is positive in quadrant 1 and quadrant 4. So in quadrant 4, it would be 2 pi minus my reference angle, 5.16. X equals the same as my reference angle and 5.16. And the question does say give answers to the nearest hundredth, so our rounding is right here. But I did go back and read the question. Anytime I go to round, I'm like, oh, I probably have to reread the question again to find out what I need to round to. On this side, I need to find my reference angle by doing cos inverse of positive 0.768. Go to my calculator. Second, cos inverse of, I still have that value, that answer, but it's negative. I could either go back and get rid of that negative sign, or I could just multiply by -1. That'll change it to positive. Cos inverse of that tells me my reference angle is 0.70. Store that reference angle as x. This time cos was negative, so it's going to be in quadrant 2, pi minus my reference angle, and in quadrant 3, pi plus my reference angle. 2.45 and 3.84. Okay. I'm going to make a little note under both of these. These were our solutions between 0 and 2 pi. And this is where we cross our fingers when we reread our question and say, did the question say solve between 0 and 2 pi? Because if it does, we'll be happy. If it doesn't, we'll be like, oh, this question takes forever. I hate math. No, don't say that. Don't say that. You should, instead, you should, oh, yes, I'm not done. I get to do more math. So exciting. That should be the expression. Is it? Do we get to do more math? Yes! We get to do more math because it says solve between negative pi and pi. And we solve between 0 and 2 pi. So we have to think back. What did we have here? We had quadrant 1 and quadrant 4. Okay. Sounded like a train. We had quadrant 1 and quadrant 4. So do you see that our quadrant 4 has to be taken out? If we draw a little picture off to the side to help us see, this one is good because we're going from 0 to pi, but we also need this one instead. So our actual answers will be 1.12. That one's fine. And this one is exactly the same as our reference angle, but negative. In the second one, we had answers in quadrants 2 and quadrants 3. Quadrant 2 and quadrant 3. This one is good because it's between 0 and pi, but this one is too high. But we have to get this angle as negative. It's actually not too bad. Can you see that that angle is negative is going to be identical to the other one, just be negative because it's 2 quadrants in the negative direction. So it'll be 2.45 as well, but negative. So now we have our solutions in the domain that they asked for. Finally, does it ask us to do more math? Part B, determine the general solution. Right, more math, yay! Right, that's the, here we go. So our general solution. So for our general solution, how do we find our general solution? We said, find your answers between 0 and 2 pi. So what we did at the beginning is actually still quite helpful, because we have our answers between 0 and 2 pi. There's 4 of them. X equals 1.12, 2.45, 3.84, and 5.16. Add 2k pi to each of them since we're in radians. Where k is an integer. Read the question one last time, and at this point, you're disappointed because you've finished. No more math to do. Okay? But don't worry. I have some questions for practice. More math to do. So we're back into being excited. 14, 13, and 12. For 14, there's a lot of quadratic. Some of them you can factor. So if you want to try factoring first, it's often, if you get good at factoring, it's shorter. But you could also use the quadratic formula as well every single time if you wanted to.